This video is going to teach you about density, and then we are going to do some basic density calculations. So density is defined as the mass per unit volume of a substance. And I tell my students to think about it this way. How compact is it, and how much does it weigh? How heavy is it compared to how big it is? Sometimes we'll pick up an object and it's small, but it feels really heavy for its size. Or we might pick up a big object and it feels really light compared to its size. That is the concept of density. And density tells us how tightly packed the particles are in a substance. So to just kind of give you a frame of reference, think about solids, liquids, and gases, our states of matter. Most students have been exposed to this, and they know that solids are packed very tightly together, and we know that solids just actually vibrate weakly around fixed points. They don't move around. They're very compact, very compressed. Liquids are just a little bit further apart, really just far enough apart so that they can glide past each other. And then we know that gases are super far apart. Very small particles, very far apart relative to their size. Now, because of the way these particles are packed together, we know that solids are the most dense state of matter. And we know that gases would be our least dense. And we know that liquids would fall somewhere in between. So if you can think about the concept of states of matter in regards to how tightly packed the particles are together, that will help you understand density. Now, another way to think about density is this. Let's say that we had 3 cubes, all identical in size or volume. All of these are 1 cubic centimeter, and that means they're 1 centimeter by 1 centimeter by 1 centimeter. But you can see that they are different substances. We have aluminum, iron, and mercury. Aluminum, this cube is only 2.07 grams. But the exact same size cube of mercury is 13.59 grams. Mercury is more dense. It has a larger mass per the same volume as compared to aluminum and iron. So we would say that aluminum is the least dense and mercury is the most dense. Now, a cool thing about density, and something that's actually very helpful, is the fact that density is a physical property of matter. And that means that if you experimentally find the density of a substance, you could probably compare that to any number of reference materials, and you could figure out what that substance is. For example, this is from the North Carolina Standard Course of Study, the reference table packets, and this is something my students get. This is only one version of probably millions of reference materials for density. But this particular chart has some of our most common metals on it. It has the specific heats, the densities, and the melting points. All we are interested in right now is the density. And you can see, if I want to know the density of copper, I can look at this packet and I can see it's 8.92 grams per cubic centimeter. I can see that gold is 19.31 grams per cubic centimeter. So it's really handy, often if you're working in any type of science, especially chemistry, to be able to look up the density of these substances. That can be really helpful. So that means, again, the fact that density is a physical property means that the substances can be experimentally identified by their densities, and you can easily find the density of a substance using any number of reference tables, textbooks. You could Google it, whatever. Now, the next thing I want you to know about density before we get into calculations is that density is a derived unit. And a derived unit means that you have a combination of units. Instead of just gram or milliliter or pound or second. We've taken those units and we've combined them because the formula is derived from something else. There are lots of derived units out there, and just to give you just a few real quick examples, speed is derived. We might look at speed in terms of miles per hour, distance over time. You could even use meter per second. If you were in physics, that's probably what you would be using. Acceleration is meter per second squared. Some people write it as meter per second, same thing. And what you see in both of these is we have a combination of units. Volume is also derived. Now that confuses my students often because they say, well, isn't volume just a liter or a milliliter? It is, but that is actually derived from length times width times height. So when we talk about volume, you may be looking at a centimeter times a centimeter times a centimeter, for example, and that's actually a cubic centimeter. Now that brings us to our next point, and this is one of the last basic things we're going to cover. The most common units for density for beginning chemistry students are either going to be grams per milliliter or gram per centimeter cubed. This is in no way, shape, or form an all-inclusive list. You could really see any mass over any volume, and it's just going to depend on the class you're taking or the application of what you're working with. If you were in industry, you might be working with pounds per gallon, but just remember it's a mass over a volume. Now, these are actually the same thing because a milliliter and a cubic centimeter are exactly the same. So I'm going to show you why. Let's say that you had a cube that was exactly 1 centimeter on each side. Well, you know that that is going to equal 1 cubic centimeter or 1 centimeter cubed, however you want to say that. It just so happens if you were to fill this cube up with liquid, you would have a volume of 1 milliliter. So a milliliter and a centimeter cubed are exactly the same thing, and sometimes in problems you will see those actually cancel each other out. So just don't let that confuse you. If you see those used interchangeably, maybe in a problem down the road. Now I want to talk specifically about the formula for density, and then we're going to be ready to do some problems. So the formula for density is density equals mass over volume. This is a really easy formula to work with. It's only got 3 parts. It's easy to rearrange. I'm going to talk about that in a second. Just remember that M is mass and V is volume. Now sometimes we're not solving for density. Sometimes we actually know the density, or we know what the substance is and we can look up the density. Sometimes we might have the mass but need to solve for the volume. Maybe it's an object with an irregular shape and I don't have a formula to solve for the volume, like if it were a cube or a cylinder. So maybe I've got to have some other way to figure it out. Maybe they give me the volume and they want the mass. In that case, you're going to have to rearrange. Rearranging this is just super easy algebra. For example, if I want to solve for mass, I could just cross multiply. So I might use the formula like this. Mass is density times volume. That's one variation. Or maybe I need to solve for volume, which means I would divide both sides by density. So I also know that volume is mass divided by density. So you have 3 ways to use this equation. Now, one last thing I'm going to add. If math is not your cup of tea and just this rearranging is just not your thing, there's also a little density triangle that I often give my students that helps them. Personally, I think it's more work to remember this than rearrange the formula, but everybody thinks differently, so you use what works for you. Density equals mass over volume. Density is mass over volume. Mass is density times volume, and volume is mass over density. So if that's something that helps you, by all means use it, whatever you have to do to get to that final answer. So now you know everything about density, you know all the basics, so we're going to jump in and do some calculations. The good news is these are so easy. If this is a review for you, maybe you are a college student and you just haven't had this in a while, you forgot how to do it, you're going to say, oh man, I can't believe I forgot that. It's just very, very easy to work with. If you're a new student, no worries, you'll get this in a hot minute. Super easy. So let's read number 1. A sample of an unknown metal has a mass of 65 grams and a volume of 23.6 cubic centimeters. Calculate the density. What I always encourage my students to do is label what you have. I've got a mass and I've got a volume, and they are asking me to solve for density. I know the formula for density. I think it's good practice to always write that formula down. It gets you used to using it, seeing it, saying it, and then you're going to know it. So density is mass over volume. The mass is 65.0 grams. Make sure you put that unit in there. That is always important in chemistry. The volume is 23.6 centimeters cubed. So when I put these in the calculator, so grab your calculators. If you're following along on the video, the best way to learn is to actually touch those calculator buttons, punch it in, and you should get about 2.75 for the number. Now let's look at those units. Gram and centimeter cubed are not going to cancel each other out. That's because it's a derived unit. So the unit is gram per centimeter cubed. That's it. You have found the density of that substance. Now, this would be a good time, if you're a beginner, for you to try one. So what I would recommend you do is pause the video right here, copy the question, and then once you've tried it, start the video back up and see if you got it right. Number 2 says, an object with a volume of 19.5 cubic centimeters is found to have a mass of 38.4 grams. What is the density of the object? They gave me volume and they gave me mass. They are asking me for density. I know that formula. I know that density is mass over volume. I know that my mass is 38.4 grams. I know that my volume is 19.5 centimeters cubed. I'm going to divide 38.4 by 19.5, so grab your calculator. You should get 1.97 grams per centimeter cubed, because again, gram and centimeter cubed are not going to cancel and you have a derived unit. Now, what you have just seen in these first 2 examples are the most simple density calculations. The good news is they just don't get a lot harder than this. The worst thing you're probably going to do is rearrange them. You may get into some down the road where you've got to convert some units over. Maybe they gave you kilograms and you've got to change it to grams or something like that. But this is the basis of it, and it's really pretty easy. So let's do 2 more examples. And we'll change it up just a little bit. So this is back to, what if they ask me to solve for mass or volume? What if I have to rearrange? Well, we've already been through that. The rearranging is very easy. I'm going to remind you that if you rearrange for mass, mass is density times volume. If you rearrange for volume, volume is mass over density. And then again, we know density is mass over volume. Same formula, 3 ways. Density is mass over volume, just happens to be the most common way that you are going to see that. And remember, you can always go back to that density triangle. Number 3 says, calculate the mass of a sample of lead that has a volume of 3.2 centimeters cubed. So they want mass this time, so I know I'm actually going to be using this formula. They gave me volume. Now, a lot of students will look at this and say, I don't have enough information. All I've got is volume. They want mass. I need something else. Well, they actually gave you that something else because they told you that what you are working with is lead. And since you know that you're working with lead, you can look at your reference table packet and you can see that lead has a density of 11.34, I'm just going to round it to 34, grams per centimeter cubed. So we know that lead is 11.34 grams per centimeter cubed, and that came from my reference table packet. So now I have volume, I have density, and I'm solving for mass. We already know that mass is density times volume. Write that equation down, and now you're ready to plug in. The density is 11.34 grams per cubic centimeter. The volume that they gave me is 3.2 cubic centimeters. Now, in this case, your cubic centimeters will cancel, leaving you with grams. That's good because they asked me to solve for mass, and gram is a unit for mass. So you're going to multiply these out, 11.34 times 3.2. And when you multiply those, you should get 36.29 grams. So punch that in, check behind me, make sure you get the right answer, and you can see that was not a big deal at all. I'm a big believer in labeling everything in the problem, so then once you've written down your equation, you just literally pick things up and you plug them right in. It's like putting your laundry away when you have a designated spot for everything to go. You just take it and you put it where it goes. Makes life a lot easier. All right, now let's look at example 4. What volume in milliliters? Now notice, not only are they asking me for volume, they're telling you I want it in milliliters. Always pay attention to that. Will be occupied by a 14.0 gram sample of mercury. So I've got mass. I'm going to label that. They told me it was mercury. Again, this is where a student might say, I don't have enough information. Anytime you think you don't have enough information, the next question you should ask yourself is, would that possibly be in my reference table packet? Is it something I could look up? The answer here is yes. So if you look at mercury, mercury has a density of we'll round to 59 grams per centimeter cubed. So I'm going to write that down. And now I have my density. They've asked me for volume, they gave me mass, they gave me density. If I look back up here, I know that I can rearrange volume, and that is going to be mass divided by density. So I'm going to write that down. Volume equals mass divided by density. The mass in this case is 14.0 grams. The density is 13.59 grams per centimeter cubed. Grams will cancel. If you divide 14.0 by 13.59, you're going to be real close to 1. I can tell that just by looking at it. And I am getting 1.03 centimeters cubed. And that makes sense because if the mass of it was 14.0 grams, we know that mercury, a cubic centimeter, weighs 13.59. That's really close to 14, so it makes sense. My volume's just right over 1. It's always good to go back and look at a problem and ask yourself, does that make sense? That's also a great strategy for multiple choice test. All right, we're going to do 2 more problems just to nail it all down, make sure you've got it. These are going to be just I'm going to call it a tiny challenge. They're really not hard. We're just kicking it up a notch, giving you a little more responsibility here. Example 5. What is the identity of 107.04 grams of a metal that occupies a volume of 12.0 centimeters cubed? I don't know what that metal is, but they gave me mass and they gave me volume. And I know that if I know mass and volume, I can find density. So that's the first thing I'm going to do. Density is mass over volume. The mass is 107.04 grams. The volume is 12.0 centimeters cubed. Get out your calculator, and if you divide 107.04 by 12.0, you're going to get 8.92 grams per centimeter cubed. Now, they did not ask me for the density. They said, hey, what is it? So I'm going to get out my reference table packet, and I'm going to see what has a density of 8.92. Just peruse through the packet. That's close, but look here. 8.92 would be copper. So the identity of this metal is copper. So if they ask you for the identity, just remember, if I can find the density, I can look that up in the packet, and then I can tell you exactly what it is. That's really cool. And again, you can do that because density is a physical property of matter. So what I would suggest is that you maybe pause the video here, copy this down, try the last one, and if you can do these problems, you can do pretty much anything a first level chemistry class is going to throw at you. You might have to combine this with some other concepts and problems down the road, but this will be very easy. So example 6 says you have a 15.0 milliliter sample of a metal. It has a mass of 203.85 grams. What is the metal? I know that density is mass over volume. They gave me the mass. They gave me the volume. Mass is 203.85 grams. The volume is 15 milliliters. Divide those numbers, and if you divide 203.85 by 15, and technically I should have written 15.0 there, but you guys get what I'm doing here. If you divide those numbers out, you're going to get 13.59 grams per milliliter. Now, something I do want to point out is I have not been emphasizing significant figures in these density problems. You know, it kind of depends on what level chemistry you're in as to how accountable you are for those. If you're in a college class, make sure that you're paying attention to those significant figures because they're very important. A lot of times in general high school chemistry, we'll just round one or two places and usually have kind of a blanket rule for that. But do always pay attention to your sig figs. Now, everything looks good. They want to know what the metal is. The density is 13.59, so let's see what has a density of 13.59, and it looks like that's going to be mercury, making sure you're looking at the right column if there's more than one concept on your table. So this is mercury. All right, that is the end of the density lesson. I might post another one down the road, maybe combining this skill with something else. This should cover any questions that you would have, again, on a beginner's level density course. And remember, density is important. You'll use it in a lot of different ways in your chemistry class, so make sure you have this as a good foundation.